Awesome. All right, so let's take a look at this factoring. What are we gonna do? Let me try this. You're thinking division. If I gave you a factor, that would be a way to go. But we don't have a factor, so we can't just divide. We've got 4 things here. Separate them out. Ew, I don't want to deal with 4 things all at once. Gross. So we're going to break it into groups. I'm going to take this pair of things together, and I'm going to take this pair of things together. So I want to do my 5x cubed plus 4x squared. We definitely want to have a plus in between. And then we've got our 10x plus 8. What do my 5x cubed and my 4x squared have in common? What can I take as a GCF? The x. How many x's can we take out? Yeah, we can take 2 x's. So we're going to take out an x squared. If I take out an x squared, what are we left with? 5x plus 4. Yep. How about on the green one, 10x and 8? What do they have in common? 2. They're both even. So when I take that out, we're left with, again, a 5x plus 4. So the fact that those 2 things match means we can take this chunk out as its own GCF. So this piece is going to go in the front. It's coming out like a GCF. We have our 5x plus 4. And our leftover bits, we've got that x squared plus 2. Is there any more factoring we can do?
Perfect square question.
So, do we have a difference of squares? Which piece? So we take the 5x plus 4, that's this guy. We pull that out, just like when we pulled the x squared out of here, and it went in front and everything else went inside parentheses. We're taking this guy out in front and everything else is going inside parentheses. It's coming out like a GCF. Just like we pulled the x squared out, we're pulling the 5x plus 4 out. So if we're looking at our further factor, my question is, first things first, is 2 a perfect square?
Yeah.
What square makes 2?
Wait, no.
2 is not a perfect square. Second option, or second piece of information on this, is there a difference in that phrase? So it's not a difference of squares. You have to be both a difference and perfect squares for that to happen. Otherwise, we're going to have imaginaries in there, and we don't want to do that. You're gross. So if this was something factorable, we would do that. This is not something factorable, so we're not going to do that. So this is our fully simplified factoring. This is the end. That's as far as we can go. We cannot find roots on this one either because it's not set equal to 0. We're only finding roots, solution zeros if this had like an equals 0, equals y, something like that. We have an expression here that we can simplify. We do not have an equation we can solve because we do not have an equal sign. So we cannot solve an expression. We can simplify, or we can factor. We cannot solve it if it does not have an equal sign. Please stop spontaneously generating equal signs. Okay. Questions on the bellwork? Because once I delete it, it goes away. Kind of. I have to capture it first. So I can post it. And then, boop. Come on. Change the page. Oh, did I unplug it? I may have unplugged it. This is not, sure as heck not responding. Boop. All right, do we have any questions on homework 1 or homework 2 in chapter 5? Do you want to go through?
Yes, let's do some questions.
I was like, we can do a couple. We're doing skills check today.
Question
5, which one in homework? Like 5-1 or 5-2?
5-2.
5-2, number 6, you said?
Yeah.
Very much like what we just did in the bellwork. So this is 5-2, number 6. That's the one, just in case I have an old version. That's the one that has my 2x cubed minus 10x squared plus 5x minus 25 equals 0. And our instructions say to factor. So that's our goal. We're trying to factor this. We're not trying to solve it. We're just trying to factor it. So this is very, very, very much like the bellwork, like what we just did. So we're going to break this up into pieces because 4 things is too many things to deal with at once. You're gross. So we're going to break this up into groups. I'm going to take the first pair of things together and the second pair of things together. We want to have a plus in between. So we're going to take our 2x cubed minus 10x squared. And yeah, it's on 5-2, it's number 6. Put it up there. And we're putting together that 5x minus 25. So very much just like what we did in the bellwork. What do these first 2 pieces have in common? And super duper close. That is a common factor, but it's not the greatest. What else do they have in common? 2 and 10.
2.
A 2. Watch out for numbers. Okay? Because that was a common factor. They wouldn't match up if I didn't go a little bit farther. So then you're headed exactly the right direction because we're going to have an x left over here and we're going to have a minus 5. So we got to make sure we're pulling out the greatest common factor. A common factor is great, but the greatest one we really, really need to have. How about on our blue one over here, 5x minus 25? What do they have in common? A 5. And so our leftover bits, we have an x minus 5. Since my x minus 5 and my x minus 5 are exactly the same piece, since this guy and this guy match exactly, we're going to pull this out as a GCF. So we're going to say, hey, this guy's out in front. This is my obnoxious little line leader, x minus 5. And then we have all this leftover stuff. This guy and this guy. I need to put them somewhere. They get their own set of parentheses. So we'll have our 2x squared plus 5. That's our factoring by grouping part. Right? Questions on here? I was going to say, was there anything more we can do on this one?
No. Maybe. Not really.
Yeah.
What do you think we can do more?
You just hesitated, so I said
I was going to say, because on your paper, there's not someone there going, are you done? Are you done? Are you done? So we got to be able to figure out if we're done on our own. So looking at the 2x squared plus 5, that would be the only thing we might be able to do stuff on. So we could check and see if you can factor it. When we have just 2 pieces with an x squared, really the only time we're going to be able to is if it's a difference of squares. And 2 is not a perfect square, 5 is not a perfect square, so this is definitely not a difference of squares. We also don't have a difference. We don't have a minus. So this is as far as we can go. But I tend to ask you guys that question because I'm not there to say, all right, let's move on to the next question when you're on the homework. You got to figure out when you're done on your own or on the test. Okay? So just because I asked the question does not always mean there's more to do. Which one did you want to look at, Abigail? 9? Okay. And then we'll probably go on with what we need to go on. So let's look at 5-2, number 9. And this one is, we're given 4f squared minus 64. And again, told to factor. And I know I'm really low over here. Sorry. What should we do first? Whenever we factor, what should we do first?
Aren't they both square roots? GCF?
GCF, boom. do ridiculous stuff because it makes y'all remember things, I promise. So check for a GCF first. What do we have? Do we have a GCF here?
4.
4. So we're going to start by taking the 4 out. So if I take 4 out of 4f squared, we're left with just our f squared. If I take 4 out of 64, what do we get? What's 64 divided by 4?
16.
16.
And that's both perfect.
They are both perfect squares, and we have a subtraction. So now we have that difference of squares pattern.
64.
I took 64 and we divided it by 4 because we pulled that out as the greatest common factor. So this piece is now a difference of squares. So that means I could write this, and I'm just going sideways over here so that people in the back can see because I know I'm super low. I could rewrite this as 4 times my f squared minus 16 we could write as 4 squared, right? 4 squared is 16, 16 is 4 squared. They mean the same thing. We can use this to do our special pattern. You can absolutely X and box it if you do not remember the special pattern for difference of squares. That's totally fine. But if we do remember it, it saves us some work because we can take the piece that was in the front, so my f goes in the front, the piece that's in the back, the 4, one side gets a 4, other side gets a 4. One factor gets a plus, one factor gets a minus. Is there any more we can do to factor this? Nope. Real big clue on that is if we have no more exponents, we for sure cannot do more to factor. If we still have an x squared, that's where we look to see if we can do more. We cannot always do more. So this is our fully factored form. Okay. Questions on this one? Okay. So, what we're gonna do today, let me move this so I can get this and I can get that. There we go. Back. Is we have, I'm gonna take notes today. Because we're doing our skills check. Yes, I've been talking about it all week, literally on the board.
Oh my God.
It is not long, I promise. It is 4 questions. It is 1 single page. That's it. Okay? So we can kind of see where we are because we've got a chapter test coming up and next week. So we need to kind of check in, see how we're doing with the first half. We've got 2 more sections in chapter 5. So this gives us kind of a halfway point check-in. And then we'll go from there, okay? So this is very much, like we've honestly done a couple of things very much like this on the homework today. Okay, I get it's time to ask questions on the homework today. All right, so we're gonna have the rest of this time where you guys can work on this. When you're done with it, if you need time to catch up on any homework, it'd be a great time to do so. You guys have before us this time to work on it. Let me know if you guys have questions on how something's worded or how something's going. All right. Do the thing. Let me know if I can help. All that jazz.